this larger, and it's not larger. I don't know why it's not larger. Why is this not larger? There it is. Okay. All right, let's go and get started. So the first ones we're going to be reviewing are your completing the squares. We did try some IXL versions yesterday with the code. The code is posted to Google Classroom with yesterday's notes. So that way if you want to practice some IXL, it's going to be on there. So again, today is our first day of review. We're going to start off with completing the square. Just like before, I'm going to go through the completing the square with an example, and then I'm going to write out some steps. And then for the other examples that we'll do, we will not be writing out the steps. We'll just go through the example. Get some colors out here. Let's start off with the first one. Example. B squared plus 2b minus 5 is equal to negative 2. When you are completing the square, step number 1, you want to move the constant to the other side. And now a question came up yesterday, which constant? Like for example, we have a negative 2 and a negative 5. How do you know which one to move? So I'm going to call this constant C. So your C value in your trinomial, that's the one we want to move to the other side. So for this example, we're going to add 5 to both sides. We're left with b squared plus 2b is equal to a negative 2 plus 5. That is a positive 3. Step number 2 is to divide by the leading coefficient. Now, in this example, the leading coefficient technically isn't there, right? We can't see it. But we know that when A is missing, what number do we have for A? Good. Yeah, so we're just going to divide by 1. Realistically, that doesn't really change anything by dividing by 1. But we still want to get into the habit of still dividing by our leading coefficient. So step number 2, divide by your leading coefficient. And we end up with the same thing. B squared plus 2b is equal to 3. Now step number 3 is where you're going to be completing the square. Okay, to complete the square, you're going to circle your b value with the symbol. Remember how we were talking yesterday? Arrows are actually important because it helps organize your thoughts. So we're going to draw an arrow. This is a positive 2. And now for completing the square, you're always going to divide by 2. It doesn't matter what your b value is, it's always divisible by 2. And we got our perfect square. So I'm going to write out our perfect square bubble of b. I'm using b because that's the letter they give us. And we got plus 1 squared. Now I'm going to go back up to where we had b divided by 2. Here, I'm going to point to it. We're going to simplify this. So 2 divided by 2, that's a positive 1. We're going to square that number. That's our new c value. And we're going to add this new c value to both sides. So right over here, I don't really have space on the left-hand side. That's okay. I'm just going to add a 1 here, and I'm going to add a 1 here. On your left-hand side, There's not much for you to do because we've already done it. So I'm going to highlight this. This right here, this trinomial needs to be factored. But we have already factored it by completing the square. So this is factoring already done. On the right side, however, we do need to actually add what it's asking us to add. So here we have 3 plus 1. We're going to bring that down, and we have 4. This is where step number 4 begins. And so step number 4 is solve by taking the square root. Okay, solve by taking the square root. So I'm going to choose to rewrite it just because I have a lot of arrows and highlighting happening. So we're going to take the square root of both sides. Now immediately when you take the square root of 4, you have a plus or minus that appears. So I'm going to write this in our notes. Anytime you solve by taking a square root, you have this plus or minus. Now this is where things can happen, okay? If you have the inside a negative, specifically in this step, it doesn't matter if it's negative before, has to be in this step. If the inside is negative, then you have no solution. But again, that only happens in this step. This is where we care. So we are looking at what we have. We have the square root of 4. And beautiful people, what's the square root of 4? Thank you. But again, we still need that plus or minus. Because this is a regular number, not a radical, it's not like the square root of 5, it's not the square root of 18 that we need to simplify, it's just 2. We're doing a mini happy dance because we're pretty much done and all we have to do is split this up. So we're going to split it up to the right, we're going to split it up to the left. This is all still step number 4, solve by taking the square root. We're going to set it equal to a positive 2. We're going to set it equal to a negative 2. We're now going to continue solving by subtracting 1. So we have b is equal to negative 3, and we have b is equal to a positive 1. And again, what does that mean? Now you don't have to show me this in your notes or on the test. You absolutely don't have to unless it's asking you to graph. This is what it means. That means that you will have an x-intercept at 1 and you will have an x-intercept at 3. So when you have your parabola, it will be an increasing function because your a is positive, and you will cross it at 2 locations, when x is 1 and when x is negative 3. Even though they give us b, it's still talking about your x-intercepts. Okay, that's kind of like, what's the whole point of us doing this? That's the whole point. We want to know where it crosses on the x-axis. I'm going to shift this down just a little bit so you guys can finish writing this down. And then the next 2 we're going to do is going to be without your steps. We'll just do them verbally. Does anyone still need time on this? Go ahead, that's fine. Okay, let's go ahead and move on to the next example. Example number 2. Shifting this up. And again, this is solving by completing the square. So beautiful people, on the test, what it's going to say is going to say solve by, sorry, let me try that again. It's going to say solve by blank. So on the test, there's going to be different methods for you solving by. And solving by, we have factoring, solving by completing the square, we have solve by graphing, we have solve by taking the square root. And if you do it a different way, not how it's asking, but if you do it a different way, it's going to give you nothing. It's not going to give you any credit. We'll give you a 0 on that. So what we're testing are specific methods of solving. So please make sure you know what each method looks like based off of the name. So this one again is going to ask solve by completing the square. Example 2. We have 4x squared plus 8x minus 9 is equal to negative 4. Step number 1, take your constant c, move it to the other side. I'm going to add 9 to both sides. We have 4x squared plus 8x equaling, is that 5? That is 5. Step number 2 is divide all terms by the leading coefficient. And so that 5/4 is giving me a little bit of anxiety, but don't worry. And no, you cannot convert it to a decimal. So we have x squared plus, almost wrote 8, it's not. We have 8 divided by 4, which is 2. And we're going to keep this as 5/4 because we cannot simplify that fraction. Step number 3 is to complete the square. We're going to take our b value. Again, draw the arrow pointing down. We have a positive 2. Again, just divide by 2, not because it's 2 on top, just because we're dividing always by 2. We have our perfect square, which is x plus 1 squared. We're going to travel above it just for a few seconds. So we have 1 squared, which is 1, and this is our new c value that we're going to be adding to both sides. Once again, on that left-hand side, there's not really anything for us to do because we've already done it. We need to factor, and that perfect square is the factor. On the other side, on the right-hand side, we do need to add 5/4 plus 1. In order to add this, I need common denominators. If you choose to use a calculator, you're going to have to definitely convert. So don't do that. Just do it by hand. It's going to be actually, believe it or not, easier. We're going to rewrite this as 1/1, creating 1 as a fraction. And we're going to create common denominators by multiplying top and bottom by 4. So we have top 4, bottom 4. And it seems like I'm rewriting the same thing over and over. It kind of is. We have 5/4 plus 4/4. And one last time for the addition. We have 5 plus 4, which is 9. 4th here. Now I am secretly doing a little bit of a sigh of relief because I'm like, I really didn't want an achy fraction. But we're now on step number 4. And step number 4 says solve by taking the square root. So we're going to take the square root here. We're going to take the square root here, immediately placing that plus or minus. On the left-hand side, we have left over our x plus 1. And on the other side, beautiful people, we're going to separate this out. We got a square root of 9 divided by square root of 4. We call it your quotient property. This is called the quotient property. And why I'm doing a happy dance? Because what's the square root of 9? 3. And what's the square root of 4? 2. still a fraction, but hey, at least we got to take the square root, right? And so once again, this is a fraction. That's okay. We still have a number. It's not a radical. So we split it up into 2. So we got x plus 1 is equal to a positive 3/2, and x plus 1 is equal to a negative 3/2. We're going to subtract 1, subtract 1. So we got x is equal to a 3/2 minus 1, and x is equal to a negative 3/2 minus 1. And again, we do need common denominator, so it's going to be very similar to this right here, where we had that 1. We're going to do common denominator. And so for 1, we're going to do common denominators. So if you want to rewrite it first as 1 over 1, that's okay. You can do that. Multiplying top and bottom this time by 2 because our denominator is 2. We have x is equal to 3/2 minus 2/2. And here we have a negative 3/2 minus 2/2. And I'll shift that up so you guys can see it in the back. Keep the denominator the same. We're adding, subtracting. So we have a 2 in the denominator. We have 3 minus 2, which is 1. Here we're adding. So we have 3 plus 2, which is negative 5. And the reason I'm adding here is because I have negatives and I have more negatives. So if you don't want to think of subtracting 2, you can think of adding 2 with 3 and then placing a negative on them. And so you have your 2 solutions. I'm going to pause here just for a moment so you guys can finish writing this down while I take roll. It's going to be a little bit of a break. Okay, does anyone still need more time on sample number 2? Once going twice? Okay. All right, let's go and move on. Lex, you doing okay? Okay, just making sure you're okay. All right, example number 3. We got n squared plus 4n minus 6 is equal to negative 3. For this one here, beautiful people, I am going to ask you to try to work ahead, okay? Try to work ahead. I'm going to give you maybe a minute to 2 minutes of a head start, and then I'm going to catch up. So try to work through all of your steps before I jump in here, please. beautiful people, I'm going to start trying to catch up to you guys. Hopefully that was enough time to get a head start. Step number 1 is you're going to move over that constant. So we're going to add 6 to both sides. And squared plus 4n. We got -3 plus 6. We got 3. Step number 2 is you're going to divide by the leading coefficient. In this case, our leading coefficient is 1, so we are dividing by 1. Even though it's 1, beautiful people, please don't skip this step just because we want to get you into the habit of dividing by the leading coefficient. And then we have completing the square. So completing the square, you're going to take your b value, draw an arrow, you're going to divide that value by 2, and that's going to be your perfect square. In this case, I am using n, since that's the letter they provided, and we got plus 2. Bringing it back up a little bit, we got 2 squared, which is 4, and that's the number that we're going to be adding to both sides. Now on the left-hand side, once again, there's nothing for us to do here because it's asking us to factor. We have already factored by using completing the square. So we're done. On the other side, however, we do need to add, and in this case, we're adding 3 plus 4. So we have n plus 2 squared is equal to 7. A little bit unhappy with 7, but it's not the worst thing in the world. Because when we do step number 4, which is taking the square root, we cannot simplify 7, so we're just going to keep it as the plus or minus square root of 7. So we have n plus 2 is equal to plus or minus square root of 7. In a way, it's almost better that you have a radical, just because you don't really have to split it up. Because the next step is taking that 2, so we want to get n by itself, and subtracting 2 to both sides. And instead of splitting up a positive root 7 and a negative root 7, we just need to write this as one thing, knowing there's 2 answers in it, and that -2 just goes out in front. So we have n is equal to -2 plus or minus the square root of 7. That is it. That is your answer. Yes, sir. Decimals are not allowed, only on iExcel. On the test, you have to give me an exact answer. So if you wanted to split it up, your 2 answers would be n is equal to -2 plus square root of 7, and then n is equal to -2 minus square root of 7. So that is okay if you would wish to split it up, absolutely fine. I'm typically a little bit on the lazier side. I don't want to write the same thing twice, so I just put a plus or minus here. But this right here, beautiful people, has to be plus or minus. If you only give me a plus or you only give me a minus without the other one, you're giving me half of the answer. Half of the answer is 50%. That means that's failing, right? All right, let's go ahead and get started. So this is day 1 of our review. We went through completing the square yesterday and the day before. Let's go ahead and do a few others. And then we'll spend a little bit of time reviewing, and then you'll be receiving your homework number 17, which is the homework for the section for chapter 4A, technically. All right, let's go ahead and jump in. Solve by factoring. Now, technically, you were first introduced solve by factoring in chapter 2. That's when we gave you factors. That's when we had the unit of factoring. We had our factors or our bubbles. We set them equal to 0 and solving. So you have seen this before in chapter 2. You've seen this before in chapter 3. And now you're seeing it again in chapter 4. Perhaps it's important. Example 1. N squared minus n minus 46 is equal to -4. Now, just like we did before, I'm going to give you the example. I'm going to write out some steps. And then for the next example, there will not be steps provided. We're just going to solve it. Step number 1 is you want to move everything to one side. Now when you do that, you're going to be, in our example, adding 4 to both sides. But what ends up happening is you're going to equal a 0. This is always going to happen when you're solving by factoring. There's always going to be a 0 equals. And then you're going to have your leftovers by combining like terms. Can someone do negative 46 plus 4, please? 40, 42. Next step, step number 2, once everything is over, we're going to factor. Now be careful, there's 3 different types of factoring. Remember, there's factoring by pattern, there's factoring with a leading coefficient by 1, and there's factoring by a leading coefficient that's not 1. So it all depends on what you see. So go back to, I think it was chapter 2 when we first introduced factoring. How do we factor? Here we have a trinomial. We have 3 terms. Leading coefficient is 1. So that means we're going to factor by guess and check. What are 2 numbers that multiply to a negative 42 but add up to a negative 1? Shout it out, Maureen. Say it one more time, I'm sorry. 6 and negative 7. Did we have to multiply anything here before we factored? Did we do any multiplication? So because we didn't do any multiplication, we don't have to do any division. It's not like a rainbow method. So next thing we're going to do, once we're done factoring, you're going to set each factor equal to 0 and solve for whatever letter you have. So I'm going to set n plus 6 equal to 0. I'm going to set n minus 7 is equal to 0. So I'm going to, subtract 6. N is equal to negative 6. I'm going to add 7. N is equal to a positive 7. So we have 2 answers. Again, what does this mean? Finding the answers is great, but what does it mean? It means, and now on the test you don't need to show me this unless you're graphing. It means that you're going to have 1, 2, 3, 4, 5, 6, an x-intercept at negative 6, and an x-intercept at 7. So when you're curving, it's going to go up like this. So again, why are these numbers important? Because it tells you where the x-intercepts are. We're not graphing, I just wanted to show you what that actually means. But there will be graphing on the test. Yeah, we'll do examples. Anyone still need more time on this? I do see pencils moving, so I'll pause for a moment. Actually, while you guys do that, let me go ahead and take roll. Let's go ahead and continue. Let's do the next one together. We have 5n squared. Oh, you guys cannot see that. Let's move that down. 5n squared plus 25n plus 35 is equal to 5. Again, we're going to go through those steps. However, I will not be writing them down on this example. Step number 1 is you're going to move all terms to one side. So we're going to subtract 5. Subtract 5. Again, as always, when factoring, you're going to end up with a 0. Step number 2 is to factor. What is always step number 1 with factoring? GCF, good. Thank you, everyone. I have a 5, a 25, and a 30. What's our GCF? 5. I have an n, no n. Is n part of our GCF? No. Okay, so let's divide out. Now, again, if you're doing everything, you can divide out by 5 as well here. But again, it's just 0, so nothing you do here is going to actually change 0. It's just going to be 0. So step number 2, what do we see? We see n squared plus 5n plus 6 equal to 0. And again, what do we have now? We need a factor. We have a trinomial. And because we removed the GCF, we have a leading coefficient of 1. So that means, once again, we're going to solve by factoring. Two numbers that multiply to a positive 6, but add up to a positive 5. What did we get? If you're thinking 6 and 1, I just thought of that. 6 and 1 doesn't work because that would end up being 7, not 5. Good. 3 and 2. Again, both of these are positive, so we need positives here. And now step number 3, you're going to set each factor equal to 0 and solve. So we got n plus 3 equals 0. N plus 2 is equal to 0. Subtract 3. Subtract 2. And we have our 2 solutions. Anyone still need more time on this? Okay, that's fine. Go ahead. Which one? Tell me what. We're not adding up to 1. This is just your leading coefficient being 1. We need to add up to 5. Oh. This is us just saying, hey, look, there's nothing there, so A is 1. Correct. If we pulled out a GCF and there was still a number there, then yes, we would have to do rainbow method. Here it's just guess and check. You good? Yeah. All right, let's do example number 3. On this one here, I'm going to give you a little bit of a head start. Try to do this on your own. Here's your question. 3n squared plus 9n plus 7 is equal to 7. And again, this section is asking you solve by factoring. If you can please solve by factoring, thank you. And I'll give you a little bit of a head start. Alrighty, let's give it a shot. Step number 1, you're going to move everything over. So I am moving the 7. Now, which 7? Well, the one that is on the other side. We want everything on one side. So we got 3n squared plus 9n. And this ends up being 0. So if you want to put a 0 here, that's fine. If you want to put nothing, that's also okay. Step number 2, I'm going to pull out a GCF. Now this 0 is bothering me, so I'm just going to not write it because it's bothering me. So then we're going to solve by factoring GCF. I got a 3n squared plus 9n. What's my GCF? 3n, good. So then we're going to divide by 3n. Step number 2, what do we see after we divide by 3n? We end up seeing n plus 3, good. Now, n plus 3 is what's called linear. That means the exponent on our variable n is just 1. So there is no factoring. This is already done. So what do we write for our factors? For our factors, we're going to write 3n GCF times n plus 3, which is our linear factor, and that's equal to 0. Again, I'm just going to write out what these are. This was our GCF. Step number 3, you're going to set each factor equal to 0 and solve. So we got 3n equals 0. We got n plus 3 is equal to 0. And now we're solving. Divide by 3, divide by 3. N is still equal to 0. Subtract 3, subtract 3. N is equal to a negative 3. And we have our two answers. Absolutely, absolutely. But I think on the guess and check, would you end up getting like a 3n plus 0? Yeah, that's fine. Give you a few moments to finish writing this down. Again, this is called solve by factoring. This is what you saw in chapter 2, chapter 3, and now again in chapter 4. Does anyone still need more time? Okay, that's fine, go ahead. All right, let's go and move on with stuff that we did only in chapter 4. In chapter 4, we talked about a discriminant. Now, a discriminant tells you how many answers you will have. It does not tell you what those answers are. So your discriminant is b squared minus 4ac. And we have three potential values. We can equal a positive number, we can equal 0, or we can equal a negative. And we don't necessarily minus the 0. We don't really care what that number is. It can be a positive 3/4, like a fraction, or it can be a positive 325. Doesn't matter, as long as we know if it's positive, negative, or 0. So if it is positive, this tells us we have two answers. Now I am writing solutions. If you use two answers on the test, that's perfectly okay. 0 tells us one solution. Oops, do you see how I'm doing? I wrote 1 and then I'm writing 1. And then negative, now negative is a little weird because it tells us not that we have no solution, because that's not true. No real solution. So when we come back from Thanksgiving break, after taking our first test, right? After Thanksgiving break, we're going to be talking about things that have like an imaginary answer, including I. So for right now, if it's negative, it tells us we have no real, and you have to write the word real, solutions. So let's do an example. Negative 4x squared plus 4x minus 4 is equal to negative 3. Just like before, first example, I'm going to walk you through it with some steps, and then after that, you're going to be able to do them on your own without steps. Step number 1, move all terms to one side. So I'm going to add 3, negative 4x squared plus 4x minus 1 is equal to 0. Step number 2, identify your ABCs. Now, how you do that, that's your choice. If you actually want to write A equals, B equals, I don't do that. I circle. Make sure you are taking the symbol with it, and you are leaving out the X's. The X's are letters, they're not numbers. Step number 3, you're going to plug and chug. And your formula again is b squared minus 4ac. And what I usually do is I write out the formula, but then I write out my empty bubbles, and then I fill them in here. So b was a positive 4, a was a negative 4, c was a negative 1. Now this right here, you can type it into your calculator exactly how you see it. Can someone do that for me, please, since I don't have a calculator with me? And we're going to get a number. Whenever you have it, please shout it out for me. 0, can I get a second on 0? Anyone else 0? Yeah, I see head nods. Okay, and so then this right here is not your answer. It's not your answer. That tells us how many answers we're going to get. So then because we have 0, it tells us we will have, yeah. So it will tell us we will have one solution. This is the answer to the question. It's not asking us what the answer is. It's asking us how many answers will we get. Well, we will get one answer. We will get one solution. And this is called the discriminant. Any questions about the discriminant, beautiful people? Any questions about the discriminant? Okay. Let's do 2 questions at the same time for the discriminant. And then this is going to go again rather quickly. I'm not going to be writing out the examples, so here's b. b is negative 6x squared minus 2x plus 18 is equal to 10. And then here's c. Negative 5r squared minus 10r minus 14 is equal to 0. And again, this is asking for determining how many solutions you will have. I'm going to pause here. Go ahead and start working. You can do both at the same time. You can do one at one time. It's your call. And I'm just writing out the formula for you. All right, beautiful people, shout it out for this one here for B. What was the discriminant? What is the actual number we get? What number was this equal to? Anyone? I hear 436. Anyone else? 436? I see head nods. No? 196? We're having a dispute here. Let's check. If you're using your bubbles, good. If you're not using your parentheses, that means your calculator is playing tricks on you. So you must be typing it in exactly how you see it with parentheses. Yes? I didn't subtract the 10 from the beginning. Holy moly. Who else saw that? No? A plus for you. Okay, let's do that. Because that's a little embarrassing. All right. Let's subtract 10. Follow your steps, Ms. Romadia says. So what should we get? 8? Negative 8? Positive or negative 8? Positive, good. Positive 8. And so then here we should have a, let's fix that real quick. Positive 8. And then this should be 196, I heard? Okay, better. This is positive. So that means your actual answer is 2 solutions. And then thank you for calling me out on that one. How about this one? This one's okay? Are we good with this one? With the ABCs? Yeah? Nothing to subtract here. If there was, then I would have made a mistake, but I'm very happy to see that 0. Can someone type this in for me and let me know what this is? Say it one more time. I'm sorry. Negative 118. Oh, 180. 180. Sorry, my hearing's not that well. Did I write that correct? Good? Okay. Okay, so what does that mean? Good. And again, you have to have that word real. Because there is an answer, it's just imaginary. What's that? No, imaginary like the letter I. Like really pretend. Okay, beautiful people. Why do we care about the discriminant? Because the discriminant is part of what kind of fancy formula? Quadratic. You're absolutely right. Okay, so next up, solve by quadratic formula. Solve by quadratic formula. Again, we're going to do an example. We're going to write out some steps, and then if I don't follow my own steps, please call me out on that. So one's a 9 and one's an A. I'm going to try to curve my A so it looks more of an A than a 9. I suggest you do the same. Step number 1 was solving for the quadratic formula. You want to move everything to one side. Realistically, it doesn't matter if you move everything to the right or to the left. I'm going to subtract 9a squared both sides just because I have 2 things already on the other side. If you have things to combine like terms, combine them. Here we don't have anything, so I'm going to say 0 is equal to negative 9a squared minus 9a plus 21. Now this right here, step number 2, you must have standard form. Otherwise, you don't have your correct ABCs. Step number 3, write out. Do we want to write out? No, let's identify your ABCs and then write out the formula. And then step number 4, write out the quadratic formula. So we have equals negative b plus or minus the square root, right? Remember the song? Of b squared minus 4ac all over 2a. Now, notice that I put equals. It is equal to something. Typically, we have it equals to x, but it all depends on the letter you have. So if you have letter A, like in our example, then this would not be x, this would be A. So whatever you're solving for, that's the letter you write here. So let's identify, let's do step number 3. Identify your ABCs. Here's A, here's B, here's C. Step number 4, writing out your quadratic formula. Don't be alarmed with these ABCs. I know this is A squared and A. If you don't like these A's, change them to an X. I'm just copying down the formula. And again, this A is separate, so if you want to leave it out, you can leave it out and then just write it in at the end. I'm writing this out one more time, leaving empty parentheses so I can fill in with my numbers. Step number 5 is solve. Solve using the quadratic formula. Oh, I need a spot for my A here. Filling this in, I have a B that's a negative 9. Make sure you take the symbol. I have a B that's negative 9. 4A, which is negative 9 again. And C, which is 21. And then A is negative 9. Okay, why we do the discriminant first? Because first we need to know how many answers there's going to be. So do this inside first, without the radical. I repeat, without the radical. So when you solve, do the discriminant first. And again, your b squared minus 4ac. If you get a number that's not negative, then you can proceed. If you get a number that is negative, you know there's not going to be a real solution, so don't bother solving the rest. Just write no real solutions. What did we get for the discriminant? What number is inside? 837? I hear head nods. 837? Let's check it out. So we got 9 plus or minus the square root of 837 divided by negative 18. And then we're going to simplify. First of all, we got to break this apart into two fractions. We got 9 over negative 18 plus or minus the square root of 837 divided by 18 negative. Split it up into 2. Simplify. Now, if you're, sorry, I don't know what that was. But if your radical can simplify, you must simplify your radical. Okay? And then, so we're simplifying this to 9 divided by negative 18 is negative 1/2 plus or minus. Now, beautiful people, what is a positive divided by a negative? Negative, good. Here's your negative. And what is a negative divided by a negative? Positive. So because you have a plus or minus here already, the negative kind of gets absorbed into this plus or minus. Kind of like it disappears. It just gets absorbed. And so then, if you cannot simplify further, that is your answer. Let's see if we can simplify 837. First thing I'm checking if it's a pretty number. Definitely not a pretty number. Next, I'm going to go into with my perfect squares, like 4. That doesn't work. 9. 9 works, beautiful people. 9 works. Let's see if I didn't expect 9 to work. So let's see if we can get a bigger number than 9. But 93 seems icky, so I don't think so. I'm trying 36, 42. Then we're trying, I don't know why I tried 42. It should be 49. And then we tried, what number? 64, 81. Nope. Might be it. So then let's simplify. We got negative 1/2 plus or minus. And it was 9, correct? Square root of 9 times square root of 93. Is that correct? And I'm going to fit in one more time. This is the square root of 9. What's the square root of 9? 3. Good. But what's 3 divided by 18? 3 goes into 3 ones. 3 goes into 18 6 times. So we have negative 1 over 2 plus or minus the square root of 93 over 6 as your answer. Absolutely. Because not only am I testing you for your discriminant, I'm also testing you for your quadratic formula. I'm also testing you to simplify your fractions, and I'm also testing you simplifying your radicals. It's a really good question. What did I write? 9 over 18? Oh, no, but we're taking the square root. Yeah. But yes, right here, 9 over 18 was 1/2. Yeah, so this, beautiful people, this square root of 9 became a 3, and then we simplified. This question, fair game on the test. Fair game. Okay, beautiful people. I'm going to end it here. I'm going to pass out your homework number 17. I would like for you to start on question number 9. Okay, you're going to start on question number 9. We'll start 1 through 8. 1 through 8 is completing the square. Here's what I would like for this homework. We're going to be spending a few moments on this homework. You can choose to work on your papers. You can also choose to work on whiteboards. If you are choosing to work on either mini whiteboards or the large whiteboards, just take a picture with your phone of your work and then erase. So I don't need to see everything on a sheet of paper. If you want to work on whiteboards, go ahead and find a spot on the whiteboard. You're starting at question number 9. The answers are located in the back. Follow me with your eyeballs. Follow me with your eyeballs. With your eyeballs. Eyeballs. See that blue bucket? Blue bucket? That's the answer. Beautiful. Keep up. Pass it. Push. Take one. Pass it. Okay, let's get some music going. I'll turn off the recording. All right. So we're going to continue preparing for our Chapter 4A test. Now there will be a Chapter 4B test, but that's going to happen later. So in Chapter 4A, where's my top of the page? There it is. We're going to solve by taking the square root. Okay, so when you are taking the square root, let me see if I can zoomed in. When we are solving by taking the square root, you're going to see only one term with an x in it, and that's going to be squared. So you're not going to see a trinomial with an ABC. You're only going to see one term with a squared, x squared, b squared, whatever number whatever letter they give you. So let's go ahead and start with A. 4x squared plus 3 is equal to 171. So here's what I mean by there's only going to be one x. Here it is. Here's one x that's squared. No other terms that they are providing have an x in it. Step number 1. You're going to isolate x squared. How are you going to isolate? First, you're going to add or subtract. Then, you're going to divide or multiply. So, we're going to subtract 3, both sides. We have 4x squared is equal to 171 minus 3. And that is 168. Then we're going to divide or multiply. So in this case, we need to divide. And hopefully this gives us a pretty number. And it does. It gives us 42. Step number 2, once you have your x squared by itself, you're going to take the square root and remember, whenever you take the square root of both sides, you have that plus or minus that appears. If you ever take the square root of both sides and the inside is negative, then your answer is no real solutions. That's only if the inside is negative. If the inside's not negative, don't worry about it. So for us, when we take the square root of x squared and then the square root of 42, this plus or minus appears. The index of 2, the exponent of 2 go away. We're just x equals plus or minus the square root of 42. 42 is not negative, so this does not apply. Step number 3, simplify your answer. You want to simplify your answer. For us, we have to simplify the radical. What two numbers multiply to get 42 when one of them is a perfect square? So I'm checking, this is what I'm doing on my calculator. 42 divided by 4, because 4 is a perfect square. Oh, you can't see, there it goes. Well, that can't happen. Next one we got is 9. Nope. 16 maybe? Nope. 25? Nope. 36? Nope. 7 times 7 is 49. Notice 49 is already too big. It's over 42. When you test out your perfect squares and there's nothing that goes into your radical, then that's done. That means you can't simplify. And you are done. Simplify when you can. If you cannot simplify, it's not the end of the world. Almost doing a little happy dance, right? And then you're just putting it in a box and that's your answer. Okay, let's do another one, B. This time I will not be writing out the steps. We're going to do this without that right-hand side. So let's go ahead and do just kidding, 7x squared minus 378 is equal to 0. Step number 1, we're going to isolate the x squared. We're first going to add 378 to both sides. Divide by 7. X squared is equal to 378 divided by 7, and hopefully that's a pretty number. It is 54. Once again, you're going to take the square root Immediately putting in that plus or minus, so we have x is equal to plus or minus the square root of 54. And again, we're going to double check and see if that could be simplified. So we have 54 divided by 4. That doesn't work. 54 divided by 3 times 3 is 9. Oh, and that does work. So we're going to simplify out our radicals. The plus or minus stays. We have the square root of 9 times the square root of 6. So we have x is equal to plus or minus 3 times the square root of 6 as your answer. Does anyone have any questions on this one, how we simplify? Okay. Anyone still need more time on this? Okay, let's go ahead and do another one. Example C. And this one gives us 49 x squared plus 10 is equal to 35. We're going to, again, isolate x squared. So we're going to subtract 10. We got 49 x squared is equal to, what do we get, 25? Divided by 49, divided by 49. That means x squared is equal to, now, if we type in 25 divided by 49 in the calculator, it gives us a decimal. We cannot have any decimals, okay? Decimals, big no-nos. So we have to keep it as a fraction. Now, it looks scary, but don't worry. When you take the square root and your plus or minus appears, we can use what's called the quotient property to separate out the square root of 25 on top and the square root of 49 on the bottom. From here, we can continue simplifying. So, what is the square root of 25? Good. And square root of 49? Perfect. And that is it. That's your answer. So even though sometimes it looks like a scary fraction, it can be simplified. Be careful about rationalizing the denominator. We'll do that in a few examples. We'll talk about rationalizing. Anyone have any questions on this one, on C? Okay, anyone still need more time on C? Okay, let's talk about graphing. We haven't done a lot of graphing since the beginning and end of chapter 3 and beginning of chapter 4. We haven't really done much graphing. This is going to be solved by graphing. Now, the equations they're giving you for solve by graphing are going to be in standard form. F of x is equal to negative x squared minus 8x minus 19. This right here, once again, is standard form. So when you are graphing in standard form, remember there's two parts that we need in order to get the vertex. Step number 1, we want your axis of symmetry. Remember your axis of symmetry, that's x equals negative b divided by 2a. We're going to get a number. Step number 2 is solve for your y value. Your y value is when you plug in your axis of symmetry x value into your equation. This will give you your vertex. Once you have your vertex, then we can use your axis of symmetry and your y value to find out your graph. Then, when you are graphing, we want to find out your x value. So let's take it one step at a time. I feel like I'm getting ahead of myself. Let's solve for the axis of symmetry. We got negative b divided by 2 A. Here's your B, here's your A. Your B is -8, your A is -1. You can use a calculator if you like. If you are, you have to do double bubbles. We have 8 over -2, which gives us a -4 equals x. Taking that taking that -4 as x, we're going to plug in -4 here. You're going to pick up your calculator. You're going to type in exactly how you see it. Negative parentheses -4 parentheses squared minus 8 parentheses -4 parentheses minus 19. That gives me a -3. So we're going to have our -4 and our -3 as our vertex. Next up, we're going to have our y-intercept. Now your y-intercept is just your z value. So when we identified our ABCs, our c value is the constant. So we have, for our y-intercept, 0, -19. So there's 2 pieces of information that actually we need. I know we did a lot of work already, but there's only 2 things we need. We need the vertex and we need the y-intercept. Because we can reflect the y-intercept, we can see how we can graph. Let's start to graph. Our vertex is -4, -3. And we have 0 and 19, negative. We have our axis of symmetry. And we have jumps 1, 2, 3, 4. 1, 2, 3, 4. Reflect your points over, connect, and you have graphed. Okay. Now the objective of chapter 4 is not graphing. We have already tested you on this in chapter 3. Our goal is for you to solve. Solve means, what are the x-intercepts? So whenever it's asking you to solve something that's a quadratic equation, it's asking you what are the x-intercepts. So we're going to look. So we're looking at the x-axis, and we're going to say which numbers did the parabola cross on this x-axis. So what numbers did it cross? Not a trick question. None, right? So what are the x-intercepts? What are the solutions to this equation? Well, where did it hit? Nowhere. None, right? There's no x-intercepts. So since it does not cross the x-axis, there are no real solutions. So what we see is the parabola not crossing the x-axis. And what that means is that our answer is no real solutions. Does anyone have any questions why it's no real solutions? Any questions on how to graph a quadratic? Again, this is from our previous unit. Are we good? Anyone need more time? Going once? Going twice? Okay, let's do another one. Example B. Same thing, f of x is equal to x squared plus 8x plus 12. I'm going to give you a little bit of a head start. Go ahead and try graphing. First solve your axis of symmetry, then find your y value, then find your y-intercept and your vertex, and I'm going to take roll while you guys do that. Please do that right now. Let's go ahead and I'm going to try to catch up to you guys. First thing I want to solve for is the axis of symmetry. So x is equal to negative b over 2a. Our b value is a positive 8. Our a value is 1. And then our c value is going to be 12. So that means we have a negative 8 divided by 2, which is negative 4. Is that what we got last time as well? Interesting. Then we got y value. We're going to copy down the original equation, replacing x with the value that we just solved for. We got negative 4, negative 4. We're going to type that in just like we see it into our calculator. Parentheses, negative 4. Close it, square it, plus 8, parentheses, negative 4. Close it, plus 12. And we got negative 4. So for our vertex, we get negative 4x and negative 4y. Next up, we got our y-intercept. And so for our y-intercept, we're going to have our c value. And our c value was a positive 12. Let's go ahead and graph. We got a negative 4 and a negative 4. We got to do our axis of symmetry, so dotted line. And we got 0, positive 12. As our y-intercept. Jump it over, axis of symmetry. We got 1, 2, 3, 4. 1, 2, 3, 4. And this is where you need to be careful. Don't actually connect yet. I am connecting, but I'm going to erase. Because you end up crossing the x-axis, we need to know exactly where does it cross. We can't just approximate using guesstimation, because what if I curved it out more? What if I made it more skinnier? It all depends on the actual number. So I'm going to erase this, and we're going to go into our T-chart. You're going to write out your vertex, negative 4, negative 4. And what you're looking for is we need a y value of 0. So I'm going to plug and chug some numbers. Is that enough numbers? Maybe. I don't know, but I just need one of them. If I have one y value that's 0, I can jump it over the axis of symmetry and reflect it. So I'm going to do exactly the same thing I did here. And I'm going to cheat a little bit and just type it in, the original that I already typed in. And I'm going to go -3. That gives me -3. Interesting how it all matches. -2. If this gives me -2, I'm going to chuckle. Oh. No need to chuckle. That is the 0 that we need, and that actually worked out with the arrow that I gave you. So we have -2 and 0. That's 1, 2 jumps, 1, 2 jumps, and we have our other point. Now you can connect. And so again, what's the point? Great, we graphed, but that was last unit. What's the point of chapter 4a? The point of chapter 4 is to get our intercepts. We want to know where it crosses. That's the point. So for your answer, your solution is that x is equal to -2 and x is equal to -1, 2, 3, 4, 5, and 6. So when it's asking you to find the solution to a quadratic equation, it's asking you where are the x-intercepts. That's what it's actually asking you. Does anyone have any questions on this one? Okay, let's go ahead and do 2 more. Let's go in and review. Speaking of chapter 3, let's review rewriting. So we have a equation 3x squared minus 6x minus 24 is equal to 0. I'm going to write out some steps for this one. This is one of the questions that some of you struggled with on the last test. You will see this on this test as well. Step number 1, we want it in standard form. Step number 2, you're going to solve for the axis of symmetry. You're going to solve for the y value, and you're going to get your vertex. Whenever you get your vertex, that's going to be your h comma k. So let's do that. Standard form, this is in standard form. Step number 1 is done. Step number 2, axis of symmetry. Axis of symmetry, just like we did above, is -b divided by 2a. Here's your b, here's your a, here's your c. -b over 2a gives us +6 divided by 6, which gives us an x value of 1. Y value, copy down the equation. Plug in your x value, in this case 1. Pick up your calculator, type it in exactly how you see it. 3 parentheses 1 parentheses squared. Minus 6 parentheses 1 parentheses minus 24, we get a -27. That means our vertex is 1, -27. And again, remember, our vertex is your h, comma k. So when you write it out in vertex form is y equals a times x minus h squared plus k. This is vertex form. You still have to have that memorized. And when you write in your h and k, h is always opposite, k is for keep. So we have y equals a times x, opposite of what we see. So minus 1, square it, keep the same k. Now what about a? A, I'm going to erase it, comes from this a right here. And we have 3. And this is your equation. That's the same equation, just in a different format. If you don't want to put that dot there, you don't have to. You can make it more squished. Okay, let's do some simplifying. Let's do some simplifying. Anyone still need more time on this? Need more time, going once, going twice? Okay. Let's simplify. When you are simplifying radicals, there are 2 examples that I want to show you. The first example you're pretty comfortable with. I feel like you guys are okay. And then the second example is where we haven't seen it in a little while, so I can imagine you guys struggling. So let's talk about the first example. Let's say we have the square root of 28. And it's asking you to simplify. Simplify the following radicals. When you do that, you are splitting up into perfect square times a number, if you can. Your perfect squares, and I'm going to do a little thinking bubble, are numbers that you can take a square root of, like 4, like 9, because the square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, and etc. So you're looking for numbers that multiply to get 28. Any guesses? What times what is 28? What times what is 28? 7 times 3. Is there anything else that we can get? Because 7 is not one of my perfect squares, 3 is not one of my perfect squares. Go ahead. Oh, 7 times 4. Can I get a second on that? 7 times 4? Yeah, okay. I'm happy with that because guess what? 4 is one of my perfect squares. And we know that 4 is equal to 2. Square root of 4 is 2. So then to simplify your radical, you're going to have 2 times the square root of 7, which is left over, as your answer. And again, I feel like you're okay with this. What we struggle with is something that looks like this. Three square root of 10 divided by 6 square root of 80. Whenever you have something like this with a fraction, split it up. 3, 6, both of these are outside the radical. Square root of 10, square root of 80. Now here you have a choice. Okay, here you have a choice. You can do this 2 different ways. You can simplify here if you'd like, or you can use your quotient property to put this in under one radical. You do not need to do that. You can absolutely just continue by simplifying your radicals. The reason I'm deciding to do this because I can do 10 divided by 8 and simplify that to 1 over 8. So here I'm simplifying to 1/2 times 1 over 8. And I'm going to use the quotient property again. We're going to go back and forth. I'm going to split it up with the square root on top, square root on the bottom. But what is the square root of 1? Good, just 1. And square root of 8, how do we simplify that? Split it up. What times what is 8 when one of them is a perfect square? Good, 4 and 2. So I'm going to rewrite it one more time. I got 1/2 times 1 over 4 and 2, which gives me 1/2 times 1 over 2 root 2. I'm going to put a little thinking bubble around it. This is not your answer. I repeat, this is not your answer. This is where you cannot simplify anymore. This is where you realize, hey, you have a radical in the denominator. And you cannot have a radical in the denominator. So we need to rationalize the denominator. Here's what you do. I'm going to keep it as 1/2 times 1 over 2 root 2. You can simplify by multiplying 2 times 2 and saying 4. I'm going to wait. Your choice. And you're going to multiply. I'm going to keep this separate. Top and bottom by the radical. This radical, and this radical are all the same. The reason I'm doing that is because we get, I'm going to multiply these two, you guys. This is starting to affect me. So we're going to multiply that by 2 times 2, which is 4, root 2, times root 2. 1 times 1 is 1, times root 2. Don't cross anything out. Okay? I repeat, do not cross anything out. We have 1 times root 2, that's the same. 4 times square root, what's 2 times 2? Good. And what's the square root? Thank you. Square root of 4? I'm okay, I'll deal with it later. Thank you. What's the square root of 4, beautiful people? 2, yeah. So we have now 1 times square root of 2 is just square root of 2. 4 times 2, which is 8. No, 2 inside the radical cannot simplify with 8 outside the radical. This is inside a house, this is outside a house. Can't combine them. And this is your simplified answer. So again, this right here is testing you if you know how to rationalize the denominator. It's also testing you on the quotient property because you have to use it twice. We're going to do another one like this. Does anyone still need more time on this? Go ahead. Okay, let's go and move on to another one. Again, very similar. Try to do this one ahead of me. We'll do 4 times the square root. Let me actually change that to a marker so you guys can see it better. Or a pen. 4 times the square root of 10 divided by 2 times the square root of 32. Step number 1, simplify it out. and separate it out. Now this one, I am not going to combine it under one radical. 10 divided by 32, we can't simplify. Should we simplify? Yeah, let's do it. I take it back. Let's do it. We got 2 times the square root of 10 over 32. What goes into 10 that also goes into 32? 2. So we have 2 times the square root of 5. What's 32 divided by 2? 32 divided by 2? 16, thank you. So we got 2 times the square root of 5 divided by the square root of 16. Oh, and I'm doing a mini happy dance. What's the square root of 16? I'm sorry, I didn't hear you. 4, thank you. And so we're done. 2 root 5 divided by, oh, we're not done. Guess what we can do? We can simplify one more time. 2 goes into 2 once, 2 goes into 4 twice. We have the square root of 5 divided by 2 as our answer. Any questions on this one? This one we did not have to rationalize the denominator. Let's do one more, last one for this section. And this one I will choose one that needs to rationalize the denominator so at least we can see it one more time. We have 2 times the square root of 10 divided by square root of 125. Now this one here, actually this one also doesn't require rationalizing. Watch. We got 2 times, use the quotient rule. We got 10 over 125. What goes into 10 that also goes into 125? Good. So we got the square root of 2 over 125 divided by 5. That gives us 25. Break it apart. Square root of 25. Thank you, my one person. And 2 and 5 cannot simplify, so you are done. Let's go ahead and do one last check. Or one last, not check, one last section. And then we're going to get your your homework number 17. I'll pass out homework number 17 so that way you can get started on your homework. And this is your application problems. So application questions are word problems that you ended up doing last time as well. We're going to end up having word problems this time as well on the test. So for this application problem, let me see if I can do this real quick. Nope, not working. It's okay. Okay, let's say there's a golf ball. Is hit from the top of a tower that is 24 meters high. The ball follows a parabolic path defined by the function. It just tells you that it's going to be looking like a parabola. by the path, not path, but path, h of t is equal to negative 5t squared plus 14t plus 24. T represents time in seconds. And h of t represents the height. And they want to know, the question is, determine how long the ball was in the air. So let me shift this up so you guys can see it. Give you a few moments to finish writing because I know that's a lot of writing. Okay, let's go ahead and draw this out and see what we have. Now, on the test, I do not need to see a picture. That's okay. I just want you to know kind of what's going on. So we have a tower. Here's a tower. And a ball was hit off of that tower, looking like a parabola, and eventually it hits the ground. And they want to know what is the distance, not distance, they want to know the time it spent in the air. From the moment it was hit to the moment it hit the ground, what was the time that it took? So what you're solving for is you're solving for the x-intercept. This right here, I'm going to do a little dotted line, is your y-axis. This right here, the ground, is your x-axis. So in reality, what you have looks something like that. So you're solving for your x-intercept. You have many different options to solve. You can solve by graphing, find your axis of symmetry, find your y value, graph, and then find where your y equals 0. That is your choice. You can solve by factoring using the rainbow method. You cannot solve by taking the square root because I have 2 t's. We can only do that when we have 1. And the last option is quadratic formula. If you're ever in a pinch, you can always use the quadratic formula for a quadratic equation. It's in the name. So let's do that. Let's solve using the quadratic formula. Your quadratic formula, if you recall the song, negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to shift this to a different page so I can have some space. Give you a moment to write down the quadratic formula. Going to shift this with the quadratic formula here, better to see. And we're going to start plugging in numbers. Oops, let me erase that A. We need to put a number in here. Let's go back to the original question. We want to identify, here's your A, here's your B with the symbol, and here's your C with the symbol. So we have B was 14, A was -5, C was 24, and A is -5. Remember, beautiful people, when you're solving the quadratic formula, you have to find the discriminant first. The discriminant will tell you, hey, is there a point for you to continue? It will tell you, do you have one answer, two answers, or no answers? This could be a made-up problem. It probably is a made-up problem, right? So it could be that the information they gave you is unrealistic. What if it didn't ever hit the ground? What if it hit a trampoline and it bounced off and it landed on a moving truck and the truck continues forever? Like, we don't know, right? This is a made-up question. So we have to do the discriminant first. The discriminant is the 14 squared minus 4 -5, 4 times -5 times 24. This is the inside of the radical. This is without the square root. I repeat, this is without the square root. You're going to type in exactly how you see it. And I get 676. That means, yes, continue. You will have 2 solutions. And again, this is because it is positive. It doesn't mean your answers will be positive. It just means because that number is positive, you will have 2 solutions. Now you can continue with the quadratic formula. But again, beautiful people, you already know what is inside the radical. You just solved it, so don't waste your time. Just write it in. Let's see if we can get lucky with the square root of 676. And yes, we can. Oh, happy dances all around. So that gives me 26. So we got -14 plus or minus 26 divided by -10. And because we have 2, a plus and a minus, we have to split it up. -14 plus 26 divided by -10. And -14 minus 26 divided by -10. If you are choosing to type this into a calculator, that's fine. But your numerator needs to be in parentheses, otherwise your calculator will lie to you. So you have parentheses, almost forgot, -14 plus 26 divided by -10. Let me actually show you how I'm typing in that. -14 plus 26, parenthesis, divided by -10. And I get -1.2. We got parentheses, -14 minus 26 divided by -10. And I get 4. Okay, let's take a look at our original question. I'm going to cover this up. I'll open it up in just a little bit. Take a look at our original problem and what we drew. This started at time 0. At time 0, someone, I don't know golf terminology, but someone hit the ball and it flew. They're asking how long was the ball in the air? And now we have 2 possible answers. Was the ball in the air for 4 seconds? Or was the ball in the air for a -1.2 seconds? Which one seems more realistic? Having a ball being thrown in the air for 4 seconds or going back in time a second and a little bit? Yeah, the other one seems a little ridiculous, right? How long was it in the air? Well, it's not in the air for 1.2 seconds. Like, what? That's weird. So we only have this answer. Even though it gave us 2 solutions, because this is called an application problem, because this is a real world situation, we got to make sure that our answers make sense. So we can't go back in time, we can't have a negative in our applications, and our answer is 4 seconds. Any questions? Okay, beautiful people. I'm going to pass out your homework number 17. I'm going to ask you to start. You're going to have to do all of it. Don't think that you don't have to do all of it, you will. But I'm going to ask you to start all the way